Okie doke. We are working from, if you're in 7 Excel, we're working from the Advanced 2 textbook. If you're in Math 8, this lesson is not in your blue textbook, but you do have access to it through Big Ideas Online, and the textbook pages are linked to the agenda. So we are doing lesson 13.4, area of composite figures. And it can be found on pages 572 and 573. Okay, so we've been working with perimeter. Perimeter is the edge of a figure. So we've been working with perimeter, the edge of the figure. Today we're working with area, all the squares inside the perimeter. So we're going to be working with the area, squares inside the perimeter. And remember, area, it's these squares. And there's 2 dimensions. There's length and there's width. So these squares are 2-dimensional, length and width. Therefore, our units will be squared. Okay? So the book is going to give us a composite figure like this. And remember, a composite figure is 2 or more shapes put together to create a figure. So if you wanted to, you could say, oh, I see a rectangle here and a triangle and a triangle and a square. So it's 2 or more shapes that are put together to create a figure. And in the first part, the book's going to give us composite figures on grid paper like this. Now, it's not hard. It's just tedious. So the first thing we're going to do is we're going to count all the squares that are completely colored. So the full squares that are completely colored. So when I look at this figure, the pink are all the full squares that are completely colored. And here's 1, 2, 3, 4, 4, 8, 12, 16, 20, 24, 28, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45. So I have 45 square units that are completely covered. So there's 45 square units. Now, I need to take a look at these units. It's not a complete square unit that's shaded. It's half of the square unit that's shaded. So I have 1, 2, 3, 4, 5 halves. So you could say 5 times half, which would be 2.5, or you can go half 1, half 2, half. So these 5 halves make 2.5 square units. Now I'm going to add them together. I have 45 full square units, and I've got 5 halves that make 2.5 square units. So I'm going to add those together, and it's 47.5 square units. So I've got 45 holes. This and this is 1, so that's 46. This and this is 1, so that's 47.5. Now it's nice when the square unit is cut directly in half, because 2 halves make a whole. But sometimes they're going to give you one like this. Now, if we look at this carefully, this is not a complete half. This is not a half. This is not a half. So the part that's shaded are not complete halves. So what we're going to do is we're going to try to put 2 shaded parts together that will equal a whole. So when I look at this shaded part here and this shaded part here, this is less than a half and this is a little more than a half. So if I put them together, that's going to be one hole. Now I look at this one, and just that tiny little corner is missing. I look at this, and just that tiny corner is shaded. So if I put these two together, that's a hole. Then this is less than half, and this is more than a half. If I put them together, that equals one hole. This is more than a half, just that little tiny triangle is missing. And right here is a little tiny triangle. It looks like it would fit. So they're going to make a hole. And then this and this make a hole. So I'm going to go through and I'm going to add these together. So this and this is 1, 2, 3, 4, 5. So all of these parts right here are 5 holes. So those are my 5 holes, and then I'm going to add them to all of these other hole units. And what I would recommend doing is shading it. After you've counted it, shade it so that you don't accidentally count it twice. Okay? So sometimes when the area doesn't cut the square perfectly in half, you have to piece 2 of them together to equal one hole. Okay. Then sometimes the book likes to do this to us. The book likes to give us a figure like this, like a basketball court. They're going to give us a circle and a rectangle that overlap, and they want us to find the area of this figure. So that's 19 feet, and this is 12 feet. So they want us to find the area of this composite figure. I have a circle and a rectangle that overlap. So I need to break this down into 2 shapes. I need to break this down into 2 shapes. Well, the first shape I see is a rectangle. I think rectangles are easy to work with because it's length times width. So this is the first shape that I see, my rectangle. Then the part that's not shaded is a semicircle, a half circle. So I have my 2 shapes. I have a semicircle and I have a rectangle. So the first thing I want to do is find the area of the rectangle. Now I know the area of rectangles is equal to length times width. Length times width. So at this point, it's just substitution. My length is 19 feet and my width is 12 feet. So I'm going to use my handy dandy calculator, and I'm going to find that the area of the rectangle is 228 feet squared. Okay. Now, and it may be helpful if you write that in here, 228 feet squared. And it's squared because we're counting all the square units inside. Now, I need to find the area of the semicircle, this. And I know the area of a circle is pi r squared. But remember, this is the whole circle. We want half the circle. Okay, so this is the whole circle. We want half of it. So I can divide by 2 here and divide by 2 here if I want. I can set that up ahead of time just to remind me. So now it's substitution. Pi is 3.14, And my radius, they didn't give me a radius, but they did give me the diameter. If from here to here is 12 feet on a rectangle, this would also be 12 feet. And I know that the radius is half of the diameter. So this is 6 feet. So I now have my radius. So my radius is 6 feet. And remember, according to the order of operations, exponents are done before multiplication. So I like to put my exponent in there just to remind me to do it first. So 3.14, 6 times 6 is 36. Now I'm going to use my handy dandy calculator, and I'm going to find that the area is equal to 113.04. But remember, this is the whole circle. I want half of the circle. So I'm going to divide everything by 2. So my area is actually equal to 56.52 feet squared. We're dividing it by 2 because we want half of the circle. This is only half of the circle. So it might be helpful. My area of the semicircle is 56.52 feet squared. But now I need to put them together so I can get the total area. I need the total area. Total area. So the total area is the area of the semicircle, which is 56.52, plus the area of the rectangle, which is 228. So I'm going to use my handy dandy calculator, and I'm going to add these together, and the total area is 284.52 feet squared. Let me make that look like a square. Squared. So that's what we're doing. We're finding the area of composite figures. And I think the hardest part of this is just figuring out what shapes you're going to use. Okay? So let's do another one. Let's do another one. So the book gets very fancy and gives us a shape like this. And they tell us this is 8 centimeters. And this is 8 centimeters. They're telling us this is a right angle, and this is 4.5 centimeters. They're telling us this is a right angle, and it's 6.7 centimeters. And this edge here is 11.2 centimeters. I think that's everything that they've given us. Yeah. Okay, so they've given us this figure. It's a composite figure because I see triangles, I see rectangles, I see parallelograms. This is definitely a composite figure, and we need to figure out the area of everything inside. Well, the first thing I want to do is break this down into the shapes that I see. So the first shape I see is a rectangle. I prefer to work with rectangles because rectangles are easy. It's length times width. So that's the first shape I see. Once I highlight the rectangle, it makes the rest of this a little bit easier. Here's a triangle. So there's my triangle. And then last but not least, I see a parallelogram. So these are the three shapes that I see that I'm going to be working with. So the first thing I'm going to do is find the area of the triangle. And I know that area of a triangle is 1/2 the base times the height. So 1/2 and the base times the height is where the two edges that meet the right angle. So my base is 11.2 and my height that meets the right angle is 4.5. So I'm going to use my handy dandy calculator. I'm going to multiply 11.2 times 4.5, and that is 50.4. And then I'm going to divide this whole thing by half. So the area of the triangle is equal to 25.2 centimeters squared. And if it helps you, write it in here. Okay, now let's find the area of the rectangle. Now, area of a rectangle is length times width. So when I look at my pink rectangle, the length is 8 centimeters and the width is 4.5. So I'm going to use my handy dandy calculator, and I can see that the area of the rectangle is 36 centimeters squared. So I'm going to write it in here just to help me. And last but not least, we have the parallelogram. And I know that the formula for the parallelogram, area of a parallelogram, is equal to base times height. And remember, the base and the height are where the right angle meet. It's the two measurements that touch the right angle right there. So my base is 8 centimeters and my height that touches the right angle is 6.7. I'm going to use my handy dandy calculator, and I can see that the area of the parallelogram is 53.6 centimeters squared. I'm going to write that in here. 53.6 centimeters squared. But now I have to add all three of these together for the total area. So the total area is all three of these together. So it is the triangle at 25.2 plus the rectangle at 36 plus the parallelogram at 53.6. So I'm going to use my handy dandy calculator. I'm going to add all of these together, and I can see that the total area is equal to 114.8 centimeters squared. So I think the hardest part of this lesson really is breaking the figure down into shapes that you can work with. So I highly recommend always looking for your rectangles and make sure you color them, shade them so that you can see what you're working with. It helps makes the shape, see the shapes easier. And then something else that's also going to be very helpful to you is this page that's attached to the agenda. Okay, Remember this page here. It's one of the anchor charts on the agenda. And it gives you the formulas for all the areas. The area of a square, the area of a triangle, the area of a rectangle. It gives you the area of a parallelogram, of a circle, and of a trapezoid. So when you have a composite figure, you're trying to break it down into these shapes so that you can find the areas of these shapes and then add them together. So this is what we are doing today. We are finding the area of composite figures, and it's just a matter of breaking that composite figure down into shapes that you know how to work with.